In our paper, we investigate the need for avatar self-views in virtual reality and their impact on multi-user communication scenarios. In video conferencing systems, having a self-view is a familiar and broadly employed concept that enables users to continuously monitor their appearance and impression on others. However, it is speculated that this heightened self-awareness can impact the self-perception and mental load. As personal and professional meetings progressively move to virtual spaces with 3D avatars, we explore whether self-views are a viable option in social virtual reality. For this, we designed 3 different self-view designs for multi-user VR. For our designs, we first identified design dimensions for self-views from related work and explored a variety of alternatives in a design exploration. We evaluated the VR self-views in a setup where 2 participants were seated face-to-face at the same physical table. In the virtual environment, the physical table was aligned with a virtual table placed in the middle of a living room, where the participants experienced the following self-view designs. Remote perspective view. This self-view is anchored to the remote user and inspired by the gallery view of most video conferencing solutions. Here, the local self-representation is captured from the perspective of the remote user and displayed on a screen-like surface next to the remote avatar's head. Personal mirror. This self-view is anchored to the local user. Users can initially reposition and resize it with pinch gestures. Afterwards, it follows the user's head rotation around the yaw axis, but is independent of other head movements. Miniature avatar. This self-view is a scaled-down version of the user's own 3D avatar, mirroring their body movements and facial expressions in real time. Initially, it can also be repositioned and resized with pinch gestures. However, after being placed, it is world-anchored and does not follow the user. We conducted a study with 32 participants in 16 dyads across 2 locations, comparing the 3 types of VR self-views to a baseline with no additional self-view. We utilized the Meta Quest Pro head-mounted display and the Meta avatars, which were customized individually by each participant. The participants played 2 variants of a word-guessing game. In every condition, every participant assumes the roles of an explainer, actor, and guesser. The explainer verbally explains a word without naming it, and the guesser has to guess it. The actor non-verbally acts a word out through gestures and facial expressions, and the guesser has to guess it. We interviewed participants to gain qualitative insights about their preferences and perceptions. Additionally, we inquired about their perceived usefulness of the self-view, mental load, task difficulty, self-assurance, feelings of presence, and perceived attention allocation. We also recorded the participants' eye gaze. Our main findings include: users prefer having a self-view in VR, especially during gesture-focused tasks, where they mostly use their self-view to verify if they appear as intended to the other person. This includes monitoring the tracking components to verify that a specific movement or expression is being tracked and conveyed correctly. Especially the miniature avatar was ranked most preferably by most participants. It was also found to be significantly more helpful than having no self-view. The personal mirror was the least preferred self-view and was perceived as distracting due to its anchoring to the local user. The remote perspective view was described as convenient and non-obtrusive, but also distracted from the conversation partner the most. There is no indication for an impact of VR self-views on self-perception and mental load. Based on our findings, we provide several design recommendations for self-views in multi-user VR scenarios. With our initial exploration into the effect of self-views in multi-user VR, we lay the groundwork for future investigations of this previously underexplored area. Our findings and design recommendations suggest possible research directions, and with our work, we hope to inspire and inform the design of future user-centric social VR spaces. For more information, please refer to our paper and the provided supplemental material.